Hi everyone. Today me and my team want to present about shear box test. Let me introduce myself and our team. My name is Nurabia Uzuma bintu Hazi. My metric number is 01DK820F2032. My team first is Nurul Ain Balkis binti Muhammad Azian. Metric number is 01DK80F2023. And second is Chevron Ras anak lelaki Bhaskar Naidu. Metric number is 01 DKA 20F1053. Introduction. Shear box test is a testing method used to determine the shear strength of a soil sample. Since granular soil cannot be retrieved in distrust, the soil is recompacted inside a shear box. The soil friction angle is then determined by direct shear, and the tests are carried out under saturated condition. Objective: to determine the shear strength of soil using direct shear or shear box apparatus. A direct shear test is a laboratory or field used by geotechnical engineering to measure the shear strength properties of soil or rock material, or of discontinue in soil or rock masses. Apparatus: first is direct shear device. Second is load and deformation dial gauzes.
Hello everyone, good day. So before I start, let me start by introducing myself at first. My name is Shashwindra son of Bhaskar Naidu, and my registration number is 01DK820F1053. And as you all know, I'm from section DKA3A. So today I will be explaining the part of procedures which in the shear box test. So without wasting time, let's take a look in it. Firstly, we should check the inner dimension the soil contain, and secondly, we should put the parts of the soil container together and calculate the volume of the container and also weigh the container. Place the soil in smooth layers approximately in 10 millimeters thick. If a dense sample is desired, temp the soil. Fifthly, weigh the soil container. The difference of these two is the weight of the soil. Calculate the density of the soil as well. So let's take a look the next procedures in my upcoming slide as well. Now make sure the surface of the soil plane and put the upper grating stone on the loading block on the top of the soil. Eighthly, measure the thickness of next soil specimen and apply the desired normal load and remove the shear pin also. Nextly, we should attach the dial gauge which measures the change of the volume, and also record the initial reading of the dial gauge and calibration values as well. So before proceeding to the test, all adjustments to see what there is no connection between two parts except. Okay, now let's take a look at the data analysis of the shear box test. So here we have used the normal stress, which is 0.5 kilograms over centimeter square. So you can see we should calculate the horizontal gauge proving rain reading, and also the horizontal and shear deformation in millimeters, and shear force, and also the shear stress as well. Okay, for the here I have inserted the below diagram, which is I have separated just because of the slides, so you can take a look from the previous slide until here. It just contains the first table until the end. This is the end table. The previous slide is my first table, which is all is contained in the one table. I just separated in two because of my slides. You can take a look at the both slides for a better vision as well. Okay, now for this data, I have used the normal stress of 1.0 kilogram over centimeter cube. So here also we will be searching the horizontal gauge reading, proving ring reading, and the horizontal or horizontal and shear deformation in millimeters, shear force, and also shear stress. All of these are the same as the previous table, but just I have changed the normal stress only, so the calculation will be a bit different, but all the points that we should be searched for is kind of the same. Okay, now lastly, the data analysis for the normal stress 1.5 kilograms over centimeter cube. So you can take a look. I have inserted a small table under the title, so which is the normal stress for 0.5 kilogram. It will be the shear stress of 0.692, and for the normal stress for 1.0 it will be 0.436, and for 1.5 it will be 0.376, and for 2.0 it will be 1.353 kilograms per centimeter cube. So in my in the beside I have inserted a diagram which continues the data analysis table, so you all can take a look and try to understand how does the calculation works, which is continued by the previous slide. So there is no difference. This table also is from the previous slide. It's just one table, but I have just separated because the table is too long, and I have inserted in both my slides because you all can take a better vision of those. Thank you. So nextly I would like to pass the next slide to my friend to be presented as well. Thank you.
Discussion. The advantages of using direct shear stress are direct measurement of shear strength, basic principles that are easily understood, simple and easy sample preparation, and almost all soil types can be tested. While the disadvantages are shear strength is measured only on a predefined shear plane. Distribution of stresses along the shear plane is not uniform and only total stresses are applied. Escape on the testing of dry granular material. As for water pressure cannot be measured. Conclusion. As a conclusion, the experiment of Shearbox test was conducted successfully. While conducting this experiment, there was some error occurred that have disturbed the reading of the apparatus. Firstly, the error was the apparatus error. Next, the error is parallax error. When reading the gauge reading, the eyes should read perpendicularly to the scale of the apparatus. In this experiment, the characteristics of shear strength of soil using direct shear box apparatus is higher for Chau-Hazelens soil. The data from the experiment don't reach the constant value. The horizontal displacement reading decreased after reach 2 times of constant reading. This occur may due to the error that stem from the apparatus.